doing today? Today we're going to be doing inequalities, but inequalities that may not be so obvious. How do you solve a quadratic inequality, for example? Aha, let's talk, yeah? Okay, so kindly consider the following quadratic inequality. You ready? Okay, how do you solve for x if x squared is less than or equal to 4x plus 12?
Move all that stuff to the other side.
Yeah, treat it like an equation. If it said equal to, you'd set it equal to 0 and factor, right? Do the same thing. All right. So x squared
Minus 4x. Minus 12.
minus 12 is less than or equal to 0, okay? Now the equal to 0 part is what we've been doing in this whole chapter. How to find zeros, whether they're real or complex, right? So we know how to set it equal to 0. We don't know how to set it equal to less than. But that's okay. Let's forget the less than for a minute. How do you answer this part? Can you factor that one? What multiplies to negative 12 adds to negative 4? 6 and 2, what signs? Negative 2 and positive 6? Is that good? Let's see, multiplies to negative 12 adds to positive 4. Whoops. 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 Not good, not good.
It's negative 6 and positive 2.
Yeah. Okay.
I knew something was wrong.
Negative 6 and positive 2. Multiplies to negative 12 adds to negative 4. Perfect, okay. All right, so what are the roots now? X can be what? 6 or negative 2. All right, so there's nothing different yet. We've just figured out the zeros when it is 0. But what about when it's less than 0 or negative? How do you figure that?
You have to do like that, and then you just switch the sign with it.
No, it's actually easier than that.
What?
Easier than that. All right, hang on. Let's make it easy. All right, hang on. You do what's known as a sign line test. You ever hear of a sign line test? No? Okay. Let's do a sign line test. What we're going to do is going to draw like... Maybe. All right, let's see. Let's see if you think this is the same thing. Okay. All right, shh. Focus, 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 focus. All right. I'm trying to figure out not only if it's equal to, but if it's less than, okay? All right, so don't forget, we're trying to get less than. Now look, this is known as a critical point. This is when the quadratic is 0, and this is also a critical point when the quadratic is 0. Let's label that, okay? So if this is 0, let's say this is negative 2 here, and this is and positive 6 is out here somewhere. 1, 2, 3, 4, 5, 6, right? I'm going to label it as a 0 like this and a 0 like this. These are x values, these are y values, okay? Now this is the thing. You know what this looks like. What if you graphed this? What shape would you get? A parabola. Now what kind of parabola? Smiley face, frowny face, smile, okay? In fact, if this were the x-axis, it would go like this, wouldn't it? Okay, so notice everywhere between negative 2 and 6, it's going to be either positive or negative. It can't be both. Anything before negative 2, it's got to be positive or negative. It can't change, right? So you have 3 regions. Pick something easy. What's easy to pick? 0? Okay. Now plug it in and see if it's positive or negative. Plug in 0. What's 0 minus 6? Negative. What's 0 plus 2? 2. Positive, in other words. So what's a negative times a positive? A negative. So no matter who you plug in between negative 2 and 6, you're going to get negative for y. Okay? The y value is going to be negative. All right, now remember what we're looking for. Less than 0. That is negative. So that's part of the answer, these x values. Okay. But wait, test out here too. These could give you negative 2. Who knows? What's a nice easy number to plug in out here? Negative 3 for x. Okay. Plug in negative 3. What do you get? Negative 3 minus 6? Negative 9. Negative 3 plus 2? Negative 1. The negative times a negative? It's a positive. So is that what we're looking for? No. Less than 0 means? Negative. So we don't want these x's. We want these. We don't want those. But wait, what else do you test? The other side. All the values out here, right? So pick something. 7. All right, well, make it easy. 7. What? 7 minus 6? 1. 7 plus 2? 9. 1. A positive 1 times a positive 9? Positive. All right. So how do you state the answer? When is this true? Or when is this less than or equal to 0?
Only when it's between negative 2 and 6.
Okay, so is this the answer then?
Yes, it is, sir.
You're going to allow equal to also to get the 0 part, because you're allowing equal to 0, right? The equal to? So we got it equal to here. All right, that's the answer. That's it. Done. So do you see how you do it? You use a sign line, but you're still doing the factors stuff or the root stuff first. Now, does that make sense? Well, look. Let's look at this graphically on Ziggy. Okay. Oh, can someone tell Kiefer who Ziggy is? The TI-83, yeah. Okay, so this is the idea. Between these x values, between x, listen up, between x is -2 and x is +6 inclusive, the y values of this parabola will be less than or equal to, below, or the same as the y values of this line. Is that true? Let's take a look at that graphically. Take a look at Ziggy. Where are you, Ziggy? There's Ziggy. Hang on, Ziggy. Okay. And let's graph. So in y equals, I'm going to put in x squared. I'm going to put this guy, x squared. Follow along with your own Ziggy. You should have one. And this will be my y2, 4x plus 12. And this is a way to solve to get 0, see where they intersect, right? But what we really want to see is when this is less than this, not just equal to. When these y values are below these y values. All right, so how about a zoom 4? There's the parabola. There's the line. It's sort of hard to see where the parabola y values are below the y values of the line because it's off the screen, isn't it? So what are you going to do to fix this? What isn't good? What are you going to fix? X min, X max, Y min, Y max? Y max. I got to go higher, right? To see stuff. All right, so change your window. Make your Y max, I don't know, 10 times bigger, let's say. Let's see if that's, I don't know if that's good enough. Graph. There's your parabola, and there's your line. Well, that's better, but you don't see this intersection over here. You see this one, but not this one, right?
Make the greatest x6.
X max, make it bigger, right? Make it include the 6? Okay. So how about in the window, I don't know, I'm just going to double the X max. Double it. Let's just double it. There's your parabola, and there's your line. Do you see both intersection points?
Yes.
Not quite.
Oh
Huh?
my.
Y max, I just doubled what it was. Okay, there it is. There's my window.
All right, change the freaking y max.
Change the freaking Y max? Fine.
Like freaking 10.
Well, how much?
Times 2.
Times 2? Okay, fine. Times 2. All right, is that good enough?
There we go.
There's your parabola, there's your line, there's your 2 intersection points, right? All right, so is it true? Look, doesn't this look like it's -2?
Yup.
And then 1, 2, 3, 4, 5, doesn't this look like the +6?
Yes.
Is the parabola below the line between x is -2 to 6? There you go. That's what we're asking. When is the parabola below, less than, the line? The y values of this below the y values of this. And also equal to, that would be the points of intersection. Let's check the points of intersection. How to get them? Super trace, second trace, what? 5 intersect. All right, and if you get closer to this one, it'll go there. First curve, hit enter. Second curve, hit enter. Guess, hit enter. And do you get 6? You do. All right, how about the other one? Super trace, and let's do intersect, but let's trace it back to the other, closer to the other intersection point, at least halfway there. All right, then you don't have to guess anything. First, second, and guess. Is it -2? It is. All right, so we checked graphically what we did analytically using a sign line test. This is what's new today. Have you ever done that before, a sign line test? You have that? Did they do that in Algebra 2 trig? Yeah? Okay. All right, let's practice that up. Try it again. Okay, you ready? Let's see. Ding. Let's try that again. So here's another question. Similar idea. Okay? See if we can do this one. When is x to the 4th greater than x? So how do you solve this one?
Oh my.
Right, set it like you're setting it equal to 0. Pretend it's an equation. All right, so x to the 4th minus x is greater than 0. Now pretend it's equal to, can you factor?
No.
No? Really? Greatest common factor, GCF is x. What's left if you take that out? X to the 3rd minus 1. Okay. So I'm really going to ask the question, when is it equal to 0? So I can get the critical points where it can change sign. Okay. Don't you know how to factor this even more? Yes, you do. Yeah, you forgot that yesterday, didn't you?
You might know how to, but I don't.
All right, anyone know what goes here? Remember, it's a binomial and a trinomial. What? X minus 1. What are you cubing here? Goes in front. What are you cubing here? Goes in back. And this sign matches this sign.
And then x squared.
Now, what do you do with this? You square it. What do you do with this? You square it. And then it's this times this, but change the sign. So negative 1 times x is negative x. Change the sign.
I hate this.
Now, how can you get that if you don't know the pattern? Divide. That into that. You'll get it. This is the pattern. What's being cubed? Tell me. What's being cubed? X. That goes in front. What's being cubed here? 1. That goes in back. This sign has to match this sign. Then what's this thing squared? Goes here. What's this thing squared? Goes here. What's negative 1 times x? Negative x, change the sign. That's the pattern, always. We've done this, a bunch of these. It always works out that way. Okay? So now, finish the solution. If this times this is equal to 0, then
And what?
x is 0, or x is,
X minus 1.
x minus 1 is 0, means x is,
Negative 1?
how do you get rid of the minus 1?
Plus.
Add it, right. Or x squared plus x plus 1 equals 0. All right. Remember, we started off with the 4th degree, so we're going to get 1, 2, 3, 4 roots. But what do you know about the roots of this polynomial? What does the discriminant say about this quadratic?
X plus 1, X plus 1.
Nope, not factorable.
I know, do quadratic straight.
Yeah, but before you even do the quadratic formula, what's b squared minus 4ac in here? Is it really? B squared is? No, b squared is? 1. Right? Minus 4 times a times c. It's negative.
Negative 3.
Right. So why do I care if it's negative or not? So the roots are imaginary, right? Well, remember what we're doing. We're doing a sine line on a real number line. Are there any i's in here? No. So as far as I'm concerned, for today anyway, there's no solution. Because I'm looking for real solutions, so there's no real solution. I don't have to bother with this. There's only 2 critical points. All right, so let's label them. Let's get a little sine line going.
So X is 0 is 1.
There's no real solution here, but you had the 0 here. You had a 0 here, and you had a 1 here. Use them. Okay. All right, so it can change sign at 0 or at 1. So mark 0, mark 1, and show that it's a 0 here and it's a 0 here. These are the x values. I want to know the sign of the y values. Okay, so go back up here. And, all right, what if you pick something in between, like, not 0, 0.5 or a half? Okay. Plug in a half. A half, well, that's a half. But what's a half cubed?
So why are you plugging into that?
1.5.
No, not quite.
0.25.
Wait, Mr. Garcia, Mr. Garcia.
What'd you say? Point? Not 0.25.
1.25.
0.125, right? All right. Now, why am I plugging it into here? Because that was the original question. I want to know when it's positive or negative.
Add the original question.
Yeah, but it's easier to plug into the factored form and see if it's positive or negative. Okay, focus, guys. Focus. Okay. So, we're picking a value between 0 and 1. I don't care which.
What is it, 0.2 squared?
0.5 squared.
0.5 squared?
Yeah. No, not squared. Sorry, cubed. Cubed.
I thought you said squared.
Well, you can do it in your head. What's 1/2 times 1/2 times 1/2?
I have no idea.
0.25.
What's 1/2 cubed? 0.25? No. 0.5 squared is 0.25. 0.5 cubed is 0.125. In other words, 1/8. Isn't 1/2 times 1/2 1/4 times another half is 1/8, right? Now, what's 1/8 minus 1? Positive or negative? That's all I care. Negative. A positive 1/2 times a negative is negative. So this whole region is negative. Remember what we're looking for? What are we looking for? What does this mean, positive or negative? Greater than 0 is positive, okay? So do I really care about these x values? No. All right. What do you want to pick out here?
2.
There's no 2 here. Negative something. Negative 2, negative 1, okay. How about negative 1? Well, this will be negative, right? What's negative 1 cubed? What's negative 1 minus 1? No. Negative 2. So negative 1 times a negative 2, positive or negative? Positive. All right, so this will be part of the answer. These x values over here will be part of the answer, right? Because today, in this example, we're not allowing equal to, so we're not going to keep 0 and 1 in the answer. But anything that makes it positive, we're going to keep. So less than 0, right? How about more than 0? Pick something out here. 2? Okay.
2.
All right, so 2 is positive. What's 2 cubed minus 1?
8.
8 minus 1? 7. So positive times a positive is a positive. So how do you write this answer? I don't want 0 because that makes it equal to, and I'm not allowing equal to this time, right? There's no equal to here. All right, so I'm not including 0, I'm not including 1, but I want everything to the left of 0 and everything to the right of 1. How do you write that answer?
Greater than 0.
X is greater than,
0, but less.
no, greater than 0 will be over here.
Less than 0.
X is less than 0 or X is greater than 1. Okay, that works. Okay. Remember, or means union, so all of these numbers put together with all of these numbers. Or you could write it this way.
Infinity x is greater than negative infinity.
Okay? Here's another way. Are you ready? All real numbers except those between 0 and 1. How about that? These 3 notations mean the exact same answer. You want every single real number except for these right here. Right? Because this gives you 0, this gives you 0, this gives you negative. You don't want any of that. You want positive only. Alright, so all the numbers less than 0 or greater than 1, all the numbers less than 0 or greater than 1, all real numbers erase between 0 and 1 inclusive. All right, these 3 mean the same thing. Pick one. I don't care which notation you use. They're all valid. Okay? Any questions how that works? All right, well, guess what? This is a similar question, although it doesn't look it. Are you ready? Let's try a new one. How do you solve this inequality? 4x plus 5, not quadratic, over x plus 2, it's rational,
Why did you do this?
is greater than or equal to 3. Because you can do it the same way. Okay? Set it equal to 0. And find all the critical points. Okay. This is 4.4. Yes. So 4x plus 5 over x plus 2 minus 3. Let's see when it is 0. Okay? How do you subtract 3 from a fraction? You make it a fraction. It's over 1. Now you need a common denominator.
X plus 2.
So multiply top and bottom by?
3x plus 6.
Okay. 4x plus 5 over x plus 2 minus 3x plus 6 over x plus 2. Is that what you want?
Here.
All right, so go ahead and subtract.
X.
You get x
Minus 1.
minus 1. Okay, x minus 1 over
X plus 2.
x plus 2 is equal to 0. Well, when is a fraction equal to 0?
When the bottom is equal to...
When the top is 0, like 0 halves is 0, isn't it? Okay, not 3 halves isn't 0, but 0 halves is 0. 3 fifths isn't 0, but 0 fifths is 0, right? So if the top is 0, all right, so what makes the top 0? X equals?
1.
1. That's the critical point. But there's a super critical point. Okay, because this is a fraction. I'm worried about negative 2 also. Why? That makes it undefined. And the function can do wacky things when you have undefined. It can change sign. Okay, so we're going to do a sign line including x equals
1 and 2.
1 or negative 2. Let's do it. All right, so here's your sign line. It's basically like an x-axis, right? Let's label the 1 and the negative 2, okay? So if this is the origin, here's the negative 2, and here's the 1. Right? Now the 1 is a 0, but the negative 2 is undefined. That's how I label that. Okay? Now what I want to know is what the sign of this is, because remember the original question, I want to know not only if it's equal to 0, but greater than. Alright, so I've got equal to 0. One of the answers is x equals 1. But what about greater than 0? Well, pick something in here. 0? Okay. Or negative 1, I don't care.
32.
No, not 32, that's over here. Alright, shh. Pick 0 or pick negative 1, right? Alright, 0. 0 minus 1 is positive or negative. And 0 plus 2 is positive or negative. So negative divided by a positive is negative. So the y values between negative 2 and 1 are going to be negative. Alright, pick something less than negative 2. Negative 3. Negative 3 minus 1 is positive or negative? Negative. Negative 3 plus 2 is positive or negative? Negative. Negative over negative is positive. So this region, these x values will give you positive y values. Isn't that what you want? Greater than or equal to 0, right? Okay. What about out here? What are you going to pick? 12 is, okay, 12 works. 12 minus 1 is positive or negative? Positive. 12 plus 2 is positive or negative? Positive over positive? Positive. Okay. So now what's the answer? How do you state all the x values that make this equal to 0 or positive? X is greater than negative 2? X is less than negative 2, or x is greater than 1, but what about equal to 1? Yeah, because we want it to be equal to 0. How about equal to negative 2? No, because that's undefined, not equal to 0. That's u, right? Undefined. Okay? Could you write that in interval notation?
Yeah, you can.
Sure you can. X is a member of what? Union what?
Oh, I hate this. I swear.
Well, I thought you said, yeah, you can.
I just said because I don't.
Oh, yeah, okay. All right, I want all the numbers less than negative 2. How do you write that?
Like going up.
Negative infinity up to negative 2. What goes here? You start at 1 and you go up to positive infinity. Okay, this notation and this notation are not saying the same thing. What's wrong? There's something wrong. These are not the same. How do you get the equal to part? You have to write. You got to put the square bracket here. Okay. All right, there you go. So you write it this way or write it this way. Same thing. Okay? All right, so here's a typical question. Take a look at the homework page. Tonight's homework page is, boom, page 273, multiples of 10. All right, so let's take a look at a question like that. Take a look at 71.
71.
Ah, yes. There you go. Yep. All right.
Stop singing. Stop singing. Please stop.
In fact, you know what? I'm going to print another one for you. Yeah. It's on the printer. All righty. So, are you ready? It should be on the printer. Document was sent. Is it there? Yeah, okay, good. All righty. Oh, you need a book too, by the way. You don't have this book, do you? Were you guys using this book in the other class? You have this? Okay. All righty. So take a look at 71. All right? 71 on page 275, actually. The homework starts on 273, but it ends on 275. All right, so, whoops. Tonight's homework starts on page 273. Multiples of 10 goes all the way to 275. All right, so take a look at page 275, number 71. You're doing 70, which is similar. Okay? Here we go. Marissa is thinking of leaving her $1,000 a week job. What? If you got $1,000 a week paycheck, would you leave that job?
Oh my gosh.
No, really? Maybe nowadays, I don't know. Okay, hang on. And she's, instead of having a normal 9-to-5 paycheck type job, she was thinking of buying this computer resale shop. According to the financial records of the firm, the profits in dollars of the company for different amounts of computers sold is in this table. All right, part A. do a scatter plot. Remember scatter plots?
Oh my God.
Oh, jeez. Okay, how do you do a scatter plot?
You don't.
You do.
You do the
How do you enter the numbers?
Go to the list.
Wait, list. Yeah, where do you put the list? Stat, edit. Okay. All right, so let's enter these numbers. All right. So I'm just entering the first column is L1. These are my X values. If I sell 0 computers, I get a certain profit. 4 computers, I get a certain profit. So forth. 7 and 12. And what else we got? We got 18. I'm just copying the numbers from the book. You should be following along. Make sure you know how to do this. 23 and 29. I'm just copying page 275, number 71. Huh? You go to Stat, Edit. Okay. All right, now let me throw in the Y values, the profits under L2. Huh? I'm alive, it's okay. Negative 1,500. Okay, so that's not a good profit, is it? If you sell 0 computers, you get a negative profit. Yeah, not good. All right, minus negative 522. That's not good either. $54 a week. Yeah, that'll buy some bread, I guess. 775. Well, we're getting close. She wants to break 1,000, right? Ooh, 1184. This is looking good. Okay, 1132
See, this isn't steady.
and 653. Yeah, remember the last time we did this, we did a linear regression. This is not linear. How do you graph? Second, y equals a stat plot. Make sure you turn one of these on. Do you have any of these on? Nope. So hit enter and hit enter. Now it's on. You want to highlight this if it's not highlighted, and you're using L1 and L2. And I don't care. Pick your favorite symbol. Now how do you set the window for this? Zoom.
Super tree.
No, zoom. 9 sets the window up for you. So is it a line? Whoops, wait, let me get rid of that. Wait, where's all this junk? I don't want that from the previous question, go away. Okay, so look, it's not a line, is it? So we're not doing linear regression today. Listen up, shh. We're not doing linear regression today, we're doing non-linear regression. Okay, so what shape do you think that is? A parabola. Okay, so part A. Use a graphing utility to draw the scatter plot of the data with the number of computers sold as the independent variable, or in other words, X or L1. Part B. Find the quadratic function of best fit. All right, so go to Stat, Calc. It's not 4, which is what we used to do. Which one? It's 5. Try it. Type mismatch usually means you didn't enter all the data right. In other words, one column is longer than the other? No, that's right. That's okay. Is you have something y equals? No. What's your stat plot say? On L1, L2. It looks like you got everything you need. Zoom 9. Dim mismatch. What? That's weird. Stat, edit. You've got 1, 2, 3, 4, 5, 6, 7 numbers. You've got 1, 2, 3, 4, 5, 6, 7 numbers. Right. Oh, because you have it in L3. That says L3.
Where's L2?
I don't know, but this is using L2, so make it L3 instead. Second 3. Zoom 9. There you go. All right. It doesn't matter. You can use L3. All right, so hit enter, and you get the parabola. Look, it's ax squared plus bx plus c. A is negative 6 point something, b is 270 point something, c is negative 1,500 something. Now, how do I graph the parabola without actually typing this stuff in again? Remember the trick? I want it to type it in there for me. What's the trick for that? Remember? You forgot? Use the L1s, right. So second enter, so I don't even have to type that. Then do second L1, comma, second L2, comma, vars, y vars, function, 1. Yeah, you got to know this stuff. All right, so you get the same answer, but now it's typed in there for you.
Wait, can you go back for a second?
This is what I did. Ding.
Where's Y?
Vars, Y vars, function 1. Okay. Now, how good a match is that? Well, graph it. Does it look like a good match?
Yes.
Yeah. Remember when it's basically perfectly quadratic, yes. Now, how would you know that without graphing it? Remember that there's this thing called this, where's the R squared? Remember the R squared stuff? Right? That's called the coefficient of determination. If it's near 100%, that's good. It's hard for the R squared to become 100%. Do you have an R squared on your output? You do? I don't. How do I fix it? No? Diagnostics, right? So go to second, 0 for catalog, alpha D, and then diagnostics on. And then do it again. And look at your answer. It's basically, if you round it off to the nearest percent, it's 100%. Okay? So that's really good. Okay, so take a look at this graph. Now, part C. Using the function you just got, determine the number of computers she has to sell to make more than $1,000 a week so she can quit her job. That she's already making $1,000 a week.
18 computers.
Well, how do you know? Well, yeah, but I want to know a whole range of x values, not just one. Okay? Look. What if I make y1 equal to 1,000? And I want to find out what then?
Super trace.
Where they intersect. Super trace and intersect, right? Okay, let's do it. Second trace, intersect. And where do they intersect? 1, 2, 3. At 14.5. Okay, now, can you sell 14.5 computers?
Yes, you can.
Not usually.
Put this in half and this one is still half.
Yeah, who's going to buy it?
I would.
No, half a computer. I don't care if it's a baby one, chop it in half. How good is that? Not good. Yeah? What? Yeah? Yeah, 29 is too much. There might be more manufacturing costs involved in producing so many computers. You have to hire a lot more workers or something. There's more expense, you know. That happens, right? Okay, so I wouldn't say 14.5. I would say what? 15. I'm not rounding up. I'm saying it's got to be 14 or 15. 14 would be too low. 15 would get you over 1,000, right? All right, how about this guy? Second, trace, intersect, trace closer to that intersection point, and see what that one is. All right, enter, 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 and we get 25.4. Now, what would you say instead of 25.4? Not 26, because 26 is going on here. 25. So between 15 and 25. All right, that's your answer. X is between 15 and 25. Okay? Fine. Now, the last question is, what's the maximum profit? How do you get the max on this parabola? Second trace. Not 3, 4. Okay. Go over a little bit before it, right? Okay, let me get there. Okay, go over to the right.
Stop cheating, girl.
Ding. Okay. So your maximum profit is, remember this is dollars and cents. So how do you round this off?
101. Oh, 103. Whoa.
I usually round this off to 3 places, right? But in cents, you round off to 2. So it'll be $1,202 and 77 cents. If you sell, how many? This is almost 20. So let's make it 20. Okay? So, let's see. Y max is approximately Y of 20, which is approximately $1,202.77. The only other thing you'd want to do if this was like your test paper or homework paper is write this down. How do you write this down? That's a mess. Can you make it round off for you?
Yes, can.
You got a mode, fix 3, let's say. Okay, and then run this again. And now you write all these numbers down on your paper. There you go. That's the answer for the curve that we graphed. Alrighty? Alright, so you got questions like this on the homework. We'll go over that tomorrow. Any problems, any questions, any comments, anyone? Alright, who wanted the printout? Who wanted the notes? Ta-da! There it is. Okay, we are rendering. Okay, bye-bye, YouTube. See ya.